This section is on vertical motion, and what happens if we throw something almost directly up in the air. This arrow at the top, this shows maximum height. Down here, t is equal to 0, initial time. This point to the right, this is total time traveled, whatever that is. And this little arrow right here, this shows the half time. And the half time is important because this is when maximum height occurs. So when half the time has elapsed. Okay? Now I'm going to go through a few of the homework questions. I'm not going to work them entirely, but you will get an idea on how to get started. For number 17, we have a flare that is fired upward, and it goes past the hot air balloon, which is this little thing right here. That's our hot air balloon, and it is at a height of 2450. So what we're wanting to find out is not the time that it happens when the flare passes the balloon the first time, but the second time, so right here. Now, because we are in meters, we are going to use this equation. So we're going to substitute the information that we have, 2450, in velocity, and we're looking for time. So we're going to put everything on one side because our goal here is to factor. So we're going to start by adding 4.9 to both sides, and we're going to subtract 294. And don't forget the t. You will want to start by seeing if 294 and 2450 can be divided evenly by 4.9. And I do believe they are. So, and you're going to solve for t. So after you solve for t, you will have your answer. Remember, your answer is in seconds. For this example, we have Luis throwing an apple up to Kim. She misses it when he throws it. It goes to its maximum height and drops back down, and she catches it right here. And she catches it at a height of 40 feet, which is where she's standing. So we're wanting to know the time. How long did it take? So since this is in feet, we're going to use h is equal to v times t minus 16 t squared. And we're going to substitute the information that we have. So we're going to put 40 in for h, 56 in for v, and just like the hot air balloon one, we're going to add the 16t squared and subtract 56t from both sides, which gives us 16t squared minus 56t plus 40 is equal to 0. Now you're going to solve for t. You don't want the first time because the first time is as the apple is going up. We want the time for when she catches it. First, before you factor this, look for the greatest common factor. I will give you a hint. It is not 4. Keep going bigger. So look for the greatest common factor, factor it out first, and then go for your two parentheses. Use the bigger of the two numbers. For number 20, we're going to approach this slightly differently. The hint that the book gives you is if h is the height of the ball above the top of the tower, then h is equal to negative 98 when the ball hits the ground. Here's why. If we count h as the height of the ball above the tower, that means right here, height is 0. When it falls the 98 feet below, where you're subtracting 98 from 0, so that's why h is negative 98. So the way we're going to set this one up, and we're looking for this time right here, negative 98 is equal to, the problem has initial speed of 39.2 meters per second, so we're going to use the meter formula. 39.2 is v, and we have t, and since it's meters, 4.9 t squared. Add the 4.9 t squared, subtract the 39.2. Like this. Look for a common factor. Perhaps it is 4.9, so give it a try. By seeing a 4.9 will go evenly into those two numbers. And since this is an even problem, I will let you know that your time, your answer, is 10 seconds. Look for some more help for the review for the test coming up in the next couple of days.